Generally, the goal of a hypothesis test is to prove your point by rejecting the null hypothesis. Now, let's look at some ways to reject as often as possible. First one I like to call the honest way. And the reason I call it that is because some of the other ways are almost mathematical shortcuts. Here, we're going to get more data. Here we have two different samples. One sample is 20 out of 50, the other one is 80 out of 200. The one on the left has a sample size that's only a fourth as big as the one on the right. So we collected more data over here in this sample. But their proportion, the actual proportion of the sample that answered the way we wanted them to, is still 40% or 0.4 in both cases. So we have the same numbers effectively, we just have a bigger sample size on the right. Now let's look at how the graphs turn out when we simulate this in StatKey as a proportion test. So we're doing a left-sided test, something less than that 0.4. In here we get a p-value of 0.099, so almost 0.10 as our p-value. Over on the right, same exact setup, just more data, and what we see here is our p-value, again looking at 0.4 down here, 0.0026, about a fourth of 1%. The null hypothesis in both of these situations was that p is equal to 0.5. Now, 0.5 would be 25 out of 50 here. And to go down from 25 all the way down to 20, that could happen quite a bit. And you can see this graph says that that's really not that unlikely or that rare. Now, going from, if 0.5 over here was 100 out of 200, dropping all the way down to 80 out of 200 is actually quite a long ways to go by just pure random chance. So as your sample size gets bigger, it's going to be harder and harder to bounce so far away from the null. That's why that 0.4 and the 0.4 here are going to have such dramatically different p-values. So if there really is an effect that you're trying to detect, asking a larger sample is going to give you a much smaller p-value. Second way I like to call the clever way. And that's because with the exact same data, you can have two different ways of writing your alternative hypothesis. If I think something's going to be less than 0.5, I could write it as p is less than 0.5 or just p is not equal to. Now, when p is less than 0.5, I'm looking at a one-tailed test. I'm looking at all of the data here to the left of that 0.4. I'm using that same basic setup we used in the last example. So everything to the left over here. And over here, when I say not equal to 0.5, I have to look at things as extreme as, which means left and right of that 0.4. And when you take the left and the right and you add them together, 0.034 plus 0.034, that's going to be twice as big as the p-value we have over here. And if we had a alpha value of 0.05, this one we would reject. This one adds up to be 0.68. We would fail to reject over here. So by cleverly using a one-tailed test whenever we can, we give ourselves a better chance of rejecting. Now you have to be honest with this. If you don't know if it's going to go up or down, you have no reason to suspect something's going to increase or decrease, you can't just change your alternative at the end. You have to come up with your hypothesis statement at the beginning if you're going to do honest statistics. Last way to make it easier to reject the null hypothesis is to lower your standards, by which I mean raise your alpha value. Instead of saying, oh, 5% unlikely is unlikely enough, you could just say 10% is unlikely enough. 1 out of 10, that's pretty good for me. That's going to give you a higher chance of rejecting the null hypothesis. The problem is that you're more likely to reject it when you're not supposed to. So you're going to have more type 1 errors if you just raise your alpha value. If something is really, really important where you do not want to reject by accident, such as maybe putting someone to the death penalty, you might want to have an alpha of Something may be very small, 0.001. We have to be absolutely convinced there's only a 1 in 1,000 chance that we'll accidentally put them to death if they're innocent. So we have to have incredible evidence to show that they are guilty. So the 3 ways, once again: get more data, use one-tailed instead of two-tailed tests when it's appropriate, or raise your alpha value if it's a situation where that's a reasonable thing to do.